Hi and welcome everyone. In this video, we're going to talk about how to solve ordinary differential equations by using the substitution method or solutions by substitution. Now, before we start doing some example, let's go over some little points and then I'll show you some examples. So now, why do we use substitution? Let me just read this for you. Often, a first differential equation is not of any previously observed form. That means it's not separable. We saw that linear or exact. So the first step in solving such differential equation consists of transforming into another differential equation by means of substitution, where the new differential equation is simpler to solve. Homogeneous equations are such differential equations. We're going to see what homogeneous equations are. So sometimes if a differential equation is kind of more complicated, so we can use substitution to make it an easier differential equation. So we have the technique to solve that. Now, what is a homogeneous? The first about homogeneous equations is a function f that has this property. F of tx ty can be written as t to the power of alpha times f of x y, for alpha being a real number. So then f is said to be a homogeneous of degree alpha. These are very simple and nice examples. If I write this function, f of xy is x cubed plus y cubed, is homogeneous of degree 3. Why? It's just to, that's if that works. If I substitute x by tx and y by ty, then we get tx cubed plus ty cubed, and we know we can write this as t cubed x cubed plus t cubed y cubed, and this is just factor out t cubed, you get t cubed times x cubed plus y cubed. That property is homogeneous, but you cannot do that the same thing for this function, so this is not homogeneous. Now, what is a first order differential, a homogeneous equation? Let's look at this. A first order differential equation, we have seen that before. M of xy dx plus n of xy dy is said to be homogeneous if both coefficient functions are homogeneous functions. That means both functions, you can write m of tx ty as t to the power of alpha mx y and n of tx ty as t to the power of alpha n xy. In addition, if m and n are homogeneous function of degree alpha, we can also write m of x y as x to the power of alpha m of 1u and n of xy as x to the power of alpha n of 1u, where u can be substituted by y over x, and m of xy equals to y to the power of alpha n of v1, and n of xy is y to the power of alpha n of v1 also, and we can substitute v by x over y2. Now, property 1 and 2 suggest a substitution that can be used to solve the homogeneous differential equations, especially either of substitution vy equals to ux or x equals to vy, where u and v are new dependent variables, will reduce the homogeneous equation to a separable first order differential equation. So here, if you have this type, you can take the homogeneous equation and change it to a separable equation, and that becomes easy to solve. So now it turns, let me just read this. The example is going to show you. It turns out that either the substitution y equals to ux or x equals to vy, where we'll reduce the homogeneous differential equation into a separable differential equation. So now if we have y equals to ux, and if we want to find the derivative of that dy dx, we use the product rule. So it's u times dx dx, which is just 1, and plus x times du dx, and you can write that as u plus x times du dx. Let's look at this example that explains it very well. So we have this equation. So first of all, we look at that, we know that's homogeneous and of degree 2, and this is also homogeneous of degree 2, because if I go back here, you can, if you substitute, you do these substitutions for both functions, you are gonna get both sides to be equal. Now, so once we have this, then we can say y equals to ux, then you calculate for dy. So dy is u dx plus x du, and substitute dy into the equation. So let's see what happens. So x squared, x doesn't change, plus instead of y, you put ux. So you get u squared x squared. Dx doesn't change, and you have x squared minus, instead of y, again, you substitute ux. So this becomes ux squared, and dy here can be written as u dx plus x du. Again, it's the product rule. Now what you can do to this expression, multiply and factor it by grouping, then you get that equation. You can combine like terms, so this is just simple as algebra, and separate the variables. That's what you get. You can take this to the other side, but you can leave it on the same side and just take the integral. So of 3 sides, it doesn't make any difference if you take this to the other side, you do get the same answer. Now how do you integrate that? You can do the long division. So if you do the long division, I kind of did that for you, u plus 1 into negative u plus 1. So it's negative 1, u goes into negative u, negative 1 times negative 1 times u is negative u, negative 1 times 1 is negative 1. You know, then you draw the line and you change the signs and you combine. So this becomes 0 and this becomes 2, and that's the remainder. So the answer is negative 1 plus 2 over 1 plus u, and that's how we got it. Plus dx over x, and we know right away the integral of that is ln absolute value of x. We're going to see that right now. So I put integrating both sides, and again, so you get here the integral of negative 1 is negative u, the integral of 2 over 1 plus u, we know is 2 times ln absolute value of 1 plus u, the integral of dx over x is ln x, and the integral, this is a constant, but it's nicer to write ln absolute value of c. So once we get that, then we can resubstitute u by y over x, because we want to get rid of u, and we want to solve for y. So negative u becomes negative y over x, and here 2 ln 1 plus u becomes 2 ln 1 plus y over x plus ln x equals to ln c. And if you use the properties of logs, you can get that answer. And to refresh your memories, I did that for you. So this expression, first of all, you can find the LCD here. So that's over its x, the whole thing over x. So you get 2 ln y plus x over x plus ln x. Take minus ln c, take that to the other side, and take y over x to the right side, then you get this becomes positive and that becomes negative. And that's why the constant, instead of c, you can just say ln absolute value of c, just to use the properties of logs. So let's see what happens. You can take the exponent, the coefficient to the exponent. So that's what you get. and it's plus, so you can write 1 ln and multiply by x, and that's divided by, and there's a minus sign here, so c goes in the denominator. X's 1x cancels, so the final answer, that's why you get ln x plus y squared over cx equals to that. Then you can take the exponential of both sides, and that's, you can get both answers are good answers for this one. So there's a different way of looking at this method. Sometimes the given ordinary differential equation is in the form where the quantity y over x happens to be a common part. In this case, it is easier to, instead of saying y equals to ux, just say u equals to y over x. So even though they're mathematically equivalent, so they are the same thing. So that's a good example. So if you see this fraction in the equation, then that substitution works very well. dy dx equals to y over x plus y over x squared. So if we say u equals to y over x, then we can just find dy. So dy is going to be dy over dx. You can use the product rule. So it's going to be x times du over dx and plus u, and substitute in the original equation. So if you substitute that, then you get x times dy over dx. So we have it here. So we get that, and the right side you have u plus u squared. U's cancel, so you get x times du over dx equals to u squared. Separate the variables, so you get u to the power of -2 du equals to 1 over x dx. That's a simple separable equation, and we can solve that by integrating both sides. And if you integrate both sides and isolate u, you get that expression. Please try to do that on your own step by step. It's pretty easy, just algebra. So then at the end, we know that u is y over x, so you substitute u by y over x, and you isolate y, and that's what you get. Next, if we have this equation, so as you notice, again, we have y over x, so we can let u to be y over x, and dy over dx, again, the product rule. So you get that. So after substitution, we have, so wherever you see y over x, you just substitute that by u. So you get 3x squared plus 1 times, that's dy dx, we have it, it's right here, plus 3 times u times x squared plus x plus u plus 2 u minus 1. So I'm just substituting y over x by u. Now, if you simplify, first of all, we see right, well, you can multiply those, or take that and distribute it, and these two terms cancel each other, and basically what you're left is that and that. Separate the variables, so you're going to be left with 3x squared plus 1 du dx, or you can write 3 over and u plus 1 times u minus 1, and that's, and the right side you get 1 over x squared dx. Now, how do you integrate this? You have to use partial fraction decomposition to that, and maybe in a lecture I'll just refresh your memories on that. And this is just tangent inverse of x. So here I wrote it for you. So you need the integral of that side and that side. So partial fraction decomposition is gonna make this in two expressions, 1 over u minus 1 and minus 1 over u plus 1. And this is 1 over x squared plus 1. So you have ln of u minus 1 minus ln of u plus 2, and the integral of 1 over x squared plus 1 please refer to your calculus 2 integrating techniques uses tangent inverse of x. So use the properties of ln. So you can write that as ln u minus 1 over u plus 1 equals to tangent inverse of x plus c. And again, if you do e of both sides, that's what you get. So, and finally, if you replace u by y over x, we get that. And this is the implicit solution. What you can do, change it to isolate y, and in this case, find the explicit solution. And again, it's all algebra. Cross multiply, take the terms with y on one side, factor out y, and then isolate it. So this is what you get. And if you plot that, this is going to be the plot of the solution. Now, there are two other special cases, but I'm going to go over those on the next video. So please watch it a couple of times, try those problems to do them yourself, write them down and do it step by step, because there's some algebra steps are skipped, but try it yourself. This is easy algebra, and see if you can get the answer. Thank you for watching, and we'll meet in my next video. Have a good one.